In this video, we'll take up the Chapter 7 review homework sheet. So for question 1, they wanted me to draw two triangles which are similar and two hexagons which are congruent. So my two hexagons are horrible. So hopefully your hexagons look a bit better than mine. For question 2, they wanted me to name two similar triangles and explain why. So I provided my rationale and I told them, for example, how I knew triangle FHG is similar to triangle KHJ. For 3, they tell me that the triangles are similar. So if that is the case, then corresponding sides must be proportional in length. So yeah, I can solve for X and solve for G using that fact. For question 4, I have to first show that triangle RST is similar to triangle PSQ, and then once I prove that they're similar, corresponding sides are proportional, so then I can solve for the length of the flagpole. For question 5, this is the relationship between the areas of two similar triangles. So if I know the scale factor is 2, I take the area of the old, like the original triangle, let's say, and then multiply by 4 to find the area of the new triangle. For question 6, they just want us to find the tangent ratio, so opposite over adjacent, and then round it to 4 decimal places. For question 7, they want us to find the angles. So they want us to use inverse tan and then round it to its nearest degree. For question 8, they want us to solve for x to the nearest tenth of a meter. So it's tan ratio 2 more times actually. So just rearrange carefully and you'll be able to solve for x to the nearest tenth of a meter. For question 9, let's see, for question 9, once again, it's a tan ratio to help us solve for x, which is the vertical height of the ramp. For question 10, this one, they gave us all the lengths of the triangle, and they just wanted us to express the sine, cosine, and tan ratio in the lowest terms. For question 11, they gave us the ratios, and we basically have to solve for the angles using inverse sine or inverse cos, and yeah, just round the angles to the nearest degree. For question 12, solve for x to the nearest tenth of a meter. So for 12a, it was using the sine ratio, and 12b using the cosine ratio. If you're having trouble using the correct ratio, then just remember SOHCAHTOA and also label the sides of your right triangle. It would go a long way. For question 13 and 14, you're solving for the right triangle, which means you want to solve for all the lengths and all the interior angles. So don't forget to use the Pythagorean theorem if you already have 2 of the 3 sides. So not much more to say about 13 and 14. It's a lot of work though to solve the triangle. Question 15 and 16 are very similar. They're double right triangle problems. And unfortunately, there's not much diversity in terms of which ratio we're using. It's just tan, 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 but it is what it is. Okay, so hopefully there weren't too many problems. That's the Chapter 7 review.